Hi gents, this is the second video on moments. I'm on page 66 and I'm looking at question C, which is this one here. Now before we get too far into it, we want to do some remembering, and that is that if we're pushing in a clockwise motion, we're looking for a positive figure. If we're pushing in an anti-clockwise motion, we're looking for a negative figure. Now with just before, I think I did that one for clockwise. Clockwise, anti-clockwise, okay? Now, our formula is moments equals force multiplied by perpendicular distance. Now remember, the distance is in meters and the force is in newtons. Now, when we did our questions before and we were looking at question A and B, you'll notice that A was just a vertical force and B was a horizontal force. So they were pretty straightforward in being able to find the moments around the pivotal point. But for C, we now have an angled force. So I've got my picture here, which I've drawn already, my problem, on a piece of paper. So hopefully it's a little bit clearer for you to see. Now, because we've got an angled force, and we learned this a little while ago about angled forces, when we look for an angled force, we are looking for either a force horizontal or a force vertical, okay, to help us find the moments around C. So, this is the way I want to think of it. If we add that in there with 200 newtons, we've got a nice line in here with an arrowhead, okay, 30 degrees in there. And if you were to bring that down in there, that there would now be the force vertical, that now would be the force horizontal. We still don't know which one we need to use to work out this problem, but that is essentially what you'd be looking for, okay? So, we know the force horizontal formula is force cos multiplied by the angle. We also know that the force vertical formula is force multiplied by sine multiplied by the angle. Now, to know which one we need to use, this is the way I think of it. If I've got a vertical distance a vertical distance, I know straight away that a vertical distance is looking for a force horizontal, okay? A horizontal distance, there we go, we are looking for a force vertical. So I always try and keep that in my mind, because that there will be very important for questions moving forward too. So let's have a little go and let's work out the moments around C. So the moments around C, and we add in our arrow to say that's a positive direction, okay, is equal to force multiplied by distance. Now, if we have a look at our question here, okay, now we know with that arrowhead there, it's pushing anti-clockwise. So we know straight away that 200 newtons is, yes, that is a negative, okay? So we would add in negative 200, which is our force, and we said this is a vertical distance. So we know, yes, we need to use the force horizontal formula. So that would be multiplied by cos, and the angle is 30. Okay, multiplied by the distance, which is 167 millimeters, so convert that to meters, 0.67. So we know the moment around C, is equal to 116 newton meters, and yes, that is a negative 116 newton meters, so we put in our arrowhead, okay? So, if you had your answer like that with your arrowhead in an anti-clockwise motion, that answer would be correct. If you still want to add in a negative at the start, including your arrowhead, that answer would also be correct. Okay, gents, I'll be back a bit later on to do question D.